So this is kind of a pull it all together lesson for you, but we've really already done this lesson before. We did it when we were talking about quadratics, okay? And whenever we factored quadratics, for instance, if I had something like x squared minus 11x plus 30 equals 0, the difference is now I've got an equal sign in there, yes? Okay. No, remember we factored the left side. The first thing we did was we made it equal 0.
Wow. So then what did you like? X plus 6 is minus 6x.
Yes, yes. And then we factored. So if I try to factor this, and remember the process whenever I say factor now that should go through your head is first, GCF. Can I take out a GCF? Yes or no? Then the second question is
the cube is squared.
Is it a special pattern? A difference of two squares, a sum or difference of two cubes, a perfect square trinomial. Can I group it? If all those are no, the box is your last resort. Then we put it in the box. So as I look here, I got to put it in the box. The only thing that looks like this with 3 terms could possibly be a perfect square trinomial, but 30 is definitely not a perfect square, right? So I've got to put it in the box. What are my signs going to look like in the box?
X squared.
Both negative, so I don't have to worry about them. So what are the two terms?
-6.
Exactly. Multiplies to 30x squared, but adds to 11x.
5 and 6.
It's 5 and 6.
Negative 11, negative.
Well, but don't worry about the signs because both of them are going to be negative.
Is that all we can do?
Can you slow down? Hold on,
Yeah.
Dang.
Can you slow down?
This was actually one of the questions on the quiz.
Yeah, no, I just realized.
This is review.
This is review. That's what I said. 3 of the questions on the quiz will review anyway.
Those are the only, that's not right. Those are the only 3 I did.
It's just a grammar, or is it something that, because normally if I were to look at that outside of this class, I would do the -30 and then.
Well, but you can't isolate x that way. There's no way to isolate because the x is written twice.
Oh, okay.
All right, so now I'm going to go up and over. What's the GCF here?
X.
And how about here?
6.
And here?
X.
And here. So this factors as x minus 6, x minus 5, remembering that it still equals 0. Now, nothing new still, right? So at this point, I have 2 sets of parentheses that multiply together to give me 0. If 2 things ever multiply to give you 0, what do you know about one of those 2 things?
One of them has to equal 0.
One of them has to equal 0. So I set both pieces to 0. Set each parenthesis.
I might have messed up. I probably factored, I just didn't solve.
Equal to 0. You didn't have to solve on the quiz. I just pulled the factoring one from the quiz. So in this case, x minus 6 is 0 or x minus 5 is 0. So while you copy this, let me ask you a question.
Did you pass?
No, that's not what I was going to ask you.
I don't know my answer.
What if instead of 2 pieces, there were 3 pieces there?
Then you split the problem.
Would that mean you had a problem back here?
That is 3 pieces right there. 1, 2, 3.
No. What if I had 3 sets of parentheses instead of 2 sets of
You
parentheses?
combine them, if they're alike.
You solve all these.
You solve all 3. Still, I'm still multiplying to get 0. The number of parentheses does not matter.
I thought you said you combine them.
Combine what?
Oh, you said that the same.
Right, like I'm saying, what if you had x plus 1, x minus 2, x plus 3 equals 0?
We use these on our test.
1, 2, 3 would equal 0. So that's review. That goes back to chapter 1, right? It does. Some of y'all are looking like you've never seen that before. Okay, so let's say then, okay, tell me when you're caught up. Say let's say I ended up with something like this equals 0, okay? Now it's a little bit different. I still have two things set equal to 0, okay? 1, 2. Okay? This side is easy. I can subtract 1 and be done, right? But this side,
Combine your X's.
can't combine those x's.
You have to,
Oh,
you have to divide, you have to put one across and then divide. So you're gonna subtract one, then you have to divide it by,
And then
side.
don't you divide it?
You're saying subtract 1
No.
and divide, no.
Treat it like a whole nother, put it in the box, just treat it as another problem.
Treat it as another, you're exactly right. Treat it as another problem. Now, we're going to run into a problem when we do that, and I intentionally set this problem up like that.
You
But
and DeAndre passed this test, you have to give everyone in this class.
what multiplies to 1x squared but adds to negative 1x?
That's what I'm talking about, H dub. Get on,
Adds to 0.
get on H boogie.
I'm just going to keep teaching because y'all are obviously so concerned about your grades that you'd rather turn around and talk to everybody else than learn this. So that's fine. Your grade. Those that want to pay attention, though, we're up here.
Keep teaching. Why did you stop?
Because I just was letting you know, as y'all get in these outbursts that you frequently do, I'm just going to plow ahead. If you would like to have a conversation, you're more than welcome to step out in the hallway and have it. What multiplies to 1x squared but adds to negative 1x? I'm hearing 1 and 1, that adds to 2. I'm hearing 1 and negative 1, that adds to 0. What's the problem?
You can't, there's no number that.
There is no number. So it's a cannot be factored. So here's where you have to go back to chapter 1 again.
Cannot factor.
If you cannot factor and you need to solve,
Write the problem again.
what do right? Okay.
You could do that.
And now circle it.
I need to know what x equals.
1.
Somebody in here knows what to do. There are
You just said it.
what? Nope.
No, you minus the 1, right?
Nope.
Oh,
Chapter 1 was all about what? It starts with a Q.
You need to get X by itself.
Quadratics. How do you solve a quadratic that's equal to 0 that will not factor?
Square root.
Can we get like one word?
Oh, I hate this one.
Okay.
I was gonna say that.
Y'all were asking how is this test cumulative? You have to be able to pull your information from chapter 1 to do chapter 2. That's the beauty of algebra anyway, though, is it builds on each other.
So you got,
All the way back.
so you got positive, negative 1. Can you actually write the problem instead of the
Wait.
I'm fixing to plug it in. A is 1, B is negative 1, and C is 1. Okay? So I'm going to plug in because once it equals 0, now I haven't applied anything new here. There is no new concept. I am still reviewing you. This is still chapter 1 concepts. I gave you something multiplied together that equaled 0 and asked you to solve it. I didn't ask you to factor it first in one of the new forms.
So which one, so the one,
Okay?
the one in the first
But
one
this
is
is part of your calculator.
Huh?
The one, the first one is 8.
Yes. No, this is one answer. A, B, and C. Shh.
So x squared is
So if you can't factor it, you can do it like that.
Yes. You can always use quadratic formula. It's just messy. It's only coefficients.
Doesn't it have to be 1 because all of them? Does that have to be maybe 3?
Oh, that was helpful.
Okay, so question, what if x squared is like 4, to say.
Then A would be 4.
So
so you wouldn't square root it.
What's negative 1?
So
It's the
basically,
number in
basically
front of the x squared.
But if it was any other number, could I just go ahead and solve it in the box method?
If it would factor, absolutely. And that should always be your go-to because that's
But
easier.
even if it doesn't factor, we can still, even if it does factor,
Yeah, I
we
can't
can
see
still
that.
do it.
Yeah, that's how I look at
Right, Ms.
You
McGee?
can't see it?
No, don't use
Oh.
That light right
Use
there.
red.
It's nice.
You turn light.
Hit that other light off, please. That's just because it's glaring.
Wait, Ms. McGee, I have a
I can
question.
barely see it.
Oh, there you go.
Even if it's factorable, we could still do that.
Yes.
if we want.
Yes. It's just messy. It leaves you a lot of room for mistake because it's such a big, long formula. If you don't carry your fraction sign all the way over, if you only put it under the radical, if you get your signs mixed up, anything like that.
So you have -1 minus 4 over 2.
So I've got minus 4 over 2. And here's why we couldn't factor it. Here we go again with a chapter 1 concept. I've got the square root of a negative number.
There is no number that goes into that.
I can't do the square root of a negative number. So instead, anytime I see a negative under a
You put the
radical,
I.
I put the I. So now I've got 1 plus or minus I square root of 3 over 2.
That's your answer. I did that. Oh, I did that in my head. But why couldn't you put the I after the 3, of course? What would happen if you put the I after the 3?
Well, where's the what is the
Like under the radical.
Negative under the radical.
I don't know if you don't know, but
You don't know these.
you be flying, bro. Yeah.
Well, that's because this is review.
Good God. I can look up and you know, oh, how?
But if you put it to the
Because it's squared, it becomes positive.
Oh, but now
What if
now
it's a
it's
third?
It keeps the sign if it's a power of 3. Yeah.
It's 10:40. We got homework. Is it gonna be like that stuff?
I haven't gotten to the new stuff yet. There's not new stuff yet. Shh, 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 shh.
So you
Guys, I'm glad y'all are so enthused that you're whining the whole time, but
question,
there's
what time-
nothing
what
new
time
yet.
are we gonna be able to finish this?
Where'd you get the eye from?
You're not gonna be able to start class like this?
Probably not. Probably not.
What?
I remember doing all that.
All right, let's say. All right, I'm going to start this one out equal to 0, okay?
We cut that in half.
But you absolutely do. Good job. Before I actually factor this one, remember my very first step is to make sure it equals 0, okay? And it does equal 0. So now what I want to do,
We look back at our other steps, trying to figure out what we do.
right, well, the first step said equal to 0.
We look at this, the factoring and solving polynomials.
0 back to the.
And remember your steps, every time you see factor or you know you need to factor, you need to say, does it have a GCF? Is it a special pattern? Can I put it in the box? Okay?
Are we solving
The
these?
slash. This is a slash problem. Because I see 4 terms here, I know I need to cut it in half and take it 2 terms at a time, right? What can you take out of the first 2?
X is 2.
What's left?
You have to,
4x and 5.
then the next we have to change the sign to a positive.
That's exactly right because there's a negative in the middle.
You can do 1.
1, and what's left?
Do you just write the problem?
Plus 5.
That's,
Now,
that's interesting.
you have to change the sign there. Only the second one. Only the
So
second
then
one.
it'll be 4x plus 5.
The middle sign has to stay. What?
I can't see where did that one? Yeah.
If there's nothing to take out, I have to hold the place with a
As in
1.
the,
Alright, so it's a negative 4.
As in a
That's
GCF.
those negative.
As in a
And Ms.
GCF.
McGee, since you have the same problem on the regular ones?
Yes. Yep.
That's it?
Well, almost.
Wait, would it be x2 minus 1, 4x plus 5, parentheses
No, it's
squared?
4x plus 5, and x to the
X2
second minus 1.
Well, she said there was more.
You just, now you pull it down and it's x2 minus 1.
Yeah, she said there's more though.
My question to you is this.
0.
Is that factored completely?
Yes.
No. Why is it not factored completely?
Because you have a 4.
Not just an exponent, but what do you see with that? What do you see as in this piece here? It's squared. They're both actually what? Perfect squares. How does that factor down?
X plus 1, X minus 1.
So x plus 1 and x minus 1?
Yep.
That's your answer.
Not yet. So under factor, I'm going to add the word completely. So this is the very first pattern listed on your special pattern sheet that we learned in chapter 1. Difference of two squares. We also did about 20 of them yesterday and about 20 of them the day before yesterday.
Isn't that the one where you do low parentheses, difference?
That's cubes. Squares are different.
Now we set them all to 0.
Now we set each piece to 0 and so
I'm
on.
asking, do we solve it?
Yes.
So we have to solve
Anytime you see an equal sign in there, you need to find what x equals.
x equals 5 over 4. X equals 1 and x equals -1.
Yes. I'm going to set each one to 0 and I'm going to solve. And somebody said, can we get fractions? And you absolutely can.
And that's it.
5 over 4.
So there's one answer, two answers, three answers.
Whoa.
Did you just basically just solve the equation?
Mm-hmm.
Yeah.
Okay, I was about to say,
You want to say what it is?
I don't know what the word.
We can factor in what we call quadratic form, okay? And this is really easy if you understand factoring itself, okay? Quadratic form, let's see. Quadratic form still has 3 pieces to it, okay? But if you notice, we only put in the box whenever it was a quadratic. It had a power of 2, right?
And power 4.
Quadratic form starts with an even power here. And this power is half of the first one. Okay? And then this ends with a constant. If you ever encountered these, say again? No variable on it.
Divide everything by 2.
No, if you ever see, and you're still going to check for a GCF and all that, this one doesn't have one, but if you ever encounter this, you can actually factor this even though it's not a special pattern. If it meets these requirements, you can put it in the box, and I'm going to show you how. Exactly. All right, so my first box is x to the 4th, and my last is 5. My signs are the same, right?
3 and 2.
Quit jumping ahead.
1.
5 and 1, not 32. But if I multiply these two together, I get 5x to the 4th. Now think about this. Think about what you know about adding and what you know about multiplying. I need it.
What is that? What are you doing?
It's not.
What is a 5x to the 4?
Because you multiply the first and the last box together.
Now we actually about to do something
Yeah.
with the exponent?
We ain't never did that before.
Yes, we do. What if it has a leading coefficient? What if it started with a 2x to the 4th?
But it doesn't.
But if it did, no, you always multiply those
If
together,
you started with the 2x, you times the 2 times the c.
which would give you, right, but it's got the x on the end.
But that doesn't change anything. because you
Watch
can't
what,
add
it's going to change on this one, watch.
It's like
Watch
going
what it
back to the
changes.
previous fight and adding another.
All right, if you multiply to 5x to the 4th, but you have to add to 6x squared, okay? The coefficients are easy to find. They're what? 5 and 1. Y'all already said that. You keep saying 2 and 3, but that multiplies to 6. We got to multiply to 5, but add to 6. 2 and 3. Now look, they've got to add to an x squared, so I make them both x squared. These are going to be whatever's in the middle.
Wait, this is the.
I don't get this.
Ah! Gosh, dog it, Derry on!
That's your fault.
I was wondering. Multiply?
Dog it, damn, I did it.
You have said 2 and 3 so many times that I wrote 2 and 3.
Why you equals 6?
But 2 times 3 is not 5.
Equals 5.
Okay. Now look, so it's got to add to what's in the middle, so that means whatever exponent's in the middle is what exponents these terms are going to have, okay?
Can you stop?
What?
Like, just stop because you're confusing me. You're making this. What would Jesus
Look,
say?
y'all look. This in the middle, guys, what's in the middle is the same that's going to be in the missing 2 boxes. If it's a power of 3, then that's going to be a power of 3. If it's a power of...
If you set it up the normal way we're doing it, would you still get the same answer?
Your exponents will be off.
Why would they be off? You said we can break the problem down into 2 again.
Try it. Try it on your paper while we finish this.
I don't understand this.
All right, look. What is the GCF here? X squared, not 5, because this one doesn't have a 5 to give. Remember how yesterday we were talking about taking the GCF out, those first few problems on your sheet? And we talked about you find the greatest common factor of the coefficients and then take the most amount of x you can. What's the GCF here? 1. 5 don't have an x on it. How about here? And how about here?
5x squared.
This one doesn't have an x.
So 5.
All right, so it factors as x squared plus 1, x squared plus 5.
Okay, so I'll tell you what you got there.
You still break it down in 2 more problems.
Why can you not? You can on this one. Why?
Because
Why?
5 can't be broken down.
5 can't. Why can't this one, even though those are both perfect squares?
Where can we break it down? 1 times
1
negative
could. 1 times
Square root
1.
of 1 is 1.
It's a plus and not a minus. Squares can only be minus. Good job, Luciana.
Square is going to be minus.
It's a difference of 2 squares. It's a sum or difference of 2 cubes.
So we would not touch it.
Or when that's negative.
Right.
So we wouldn't touch it to the square root and we can't.
Correct.
I mean,
So you leave it like that?
so why couldn't
Right.
we, why couldn't
Okay,
we
so
just
you
try-
that's it?
Please don't put any more on us today.
Hold on, so why couldn't we just put, like, why wouldn't it just be like x plus 5 then x minus 5?
Because
They're not perfect squares.
Okay, wait,
And
we
the signs are plus.
Just text me the login information.
The only thing's different now is the fact that we added the X ones, because we usually don't
Correct.
worry about the X ones.
Correct.
We just worry about the
Correct.
I think that's it.
Guys, for some reason we're thinking that class is over. Gil Conder, no.
I'll take a picture of the login.
Not yet. I'm still teaching. Sit down. Plus 36 eggs.
I would teach them when we got like
Can I work
5
this one
minutes.
out? Can I work it out?
What?
I dismissed the class. Go sit down. Go sit down and finish taking your notes. Directions for this one simply say, find the solutions of the equation.
Take an X from each of them.
Take an x from each of them, okay?
And divide it by 4.
And divide it by 4. What's left?
X to the 4th.
Yeah.
10x to the second.
X to the 4. Yeah.
And 9 and 9.
Yeah.
Equals 0.
Now. What now?
Well,
It already equals
Do
0.
the little thing that you just did with the other thing.
Can I put that in the box?
Yeah.
The first exponent's even, the second one's half the first, and the last one's a constant.
You said constants.
I need two terms, same sign, that are going to multiply to 9x to the fourth,
1 and 9.
but add to 10x squared.
1 and 9.
1 and 9,
squared and
but
9.
right. 1 and 9, but I'm going to have to put the x squareds on each of them. Yep.
Break it down, break it down, break it down.
A second.
Wait, don't those have to be negative or
I'm
no?
sorry.
I think she's speaking this because we giving her the answers. I think that's the problem we have.
No, I'm just, the problem we're having is because I'm speeding her up.
Yeah, that's.
Those don't add to 10 though.
It doesn't make any
She
sense.
the answer out, she put
You know it.
She can do it.
Okay.
GCF here
You get mad at me because you did this one.
and here, GCF and GCF. So since both of my signs are minus, whenever I do this one, actually on this one I can, Tyler. Do you see why?
Yeah, because the minuses.
Now they're minuses, and now they're both perfect squares.
I pledge allegiance The library is sponsoring checkout of new book week. Students who check out one of the newly arrived books can enter a drawing for a display gift card. Winners will be drawn each day. Hundreds of new books are drawn. Latrell Johnson, yesterday's winner of checkout of new book. Latrell can go by the library and pick up her gift. The girls' soccer team will be selling Bojangles sausage biscuits in the parking lot and in front of school next Tuesday, November 7th, before school. The biscuits will cost $2. National Honor Society will have its first meeting November 10th at 11:30 in the lecture hall. All members must be in attendance unless excused by Ms. Huff or Mr. Gendering in advance. The gym is open for girls basketball.